Good morning, dear students. Welcome again. Today I am going to continue our previous lesson, that is haloalkanes and haloarenes. So today my topic in this lesson is nomenclature of haloalkanes and haloarenes. There are two names associated with every compound. The first name is called common name, or you can say trivial name, and the second one called aryupic name, that is nomenclature according to International Union of Pure and Applied Chemistry. So we can write what? There are two names associated with every compound. That is, first one common name. Common name is also called trivial name. Trivial name, or you can say general name. Second one aryupic name, that is nomenclature on the basis of international unit. The most important is aryupic name. So while writing the aryupic name of haloalkanes, some point must be considered. The first one, select the longest chain of carbon atoms containing the halogen atom. This is the first rule while writing the aryupic name of haloalkanes. The second one, number the chain so as to give the minimum number to the carbon carrying halogen atom. Means what? He select longest continuous carbon chain including halogen group. Halogen group always goes to minimum position. And the third important point is what? If multiple bonds, double or triple bond is present, then it is given preference in numbering of carbon atom. Such are called what? Iambic rules. If we consider such three rules, we can write down the iambic nomenclature of different types of haloalkanes. How to write down the correct iambic name of haloalkanes and haloarenes? For this, consider different types of examples. That is, our first example is very simple. In this example, first we consider longest continuous carbon chain, including halogen atom. Halogen atom always goes to minimum position. One thing always remember while writing the iambic name of haloalkanes: haloalkane. This is said to be what? Prefix. ALK, root word. ANE, said to be what? Suffix. So this is the generic pattern for iambic name of haloalkanes. So here we can write down what? 1, 2, 3. Halogen group always go to minimum position. Therefore, the name of this compound become what? 1-bromo. 3 carbon atom chain called what? Pro. This is the correct iambic name for this compound. You know very well, if a straight chain hydrocarbon is present, then in general or common name you can use what? Normal. So according to trivial name, the name of this compound is called what? Normal propyl bromide. And propyl bromide. In bracket, there is always written here for general name, and this name is said to be what? Iambic name. Second one, let us consider this pattern of example. The longest carbon chain contains 3 carbon atoms. So here 1, 2, 3. The iambic name for this compound become what? 2-chloro-propane. This group is said to be what? Iso. So the common or trivial name is called what? Isopropyl chloride. This is common name. This become iambic name. Third one, suppose if we consider this pattern of compound. So longest continuous carbon chain 1, 2, 3. 2 types of branching are present, chloro and methyl. First we write down the name of chloro because naming according to alphabetical order. 2-chloro, 2-methyl propane. The common name is tertiary butyl chloride. Next one, suppose if you have a given this pattern of compound, so we can write what? 1, 2, 3. 2 methyl groups are present as a substituent, so the naming of this compound become 1-chloro 2,2-dimethyl propane. This group is said to be what? Neo. You can also write neopentyl chloride. Neopentyl chloride. In bracket we write common name, and the upper name is said to be what? Ionic name. Suppose if you have a given fifth here two type of functional group are present. First functional group is double bond and the second one halogen. Double bond is always senior compared to halogen. So double bond always go to minimum position in the longest continuous chain of carbon atom. So numbering 1, 2, 3, 4, 5. We can write what? 4 bromo. Pent 2 in. In is what? Compound containing double bond. Some common terms always remember while writing the common name of organic compounds. So in notes, suppose this pattern of a straight chain alkyl group is present, then you can use what? Normal before the name of alkyl group. So the name of this alkyl group is what? Normal propyl. Suppose this pattern of alkyl group is present, we can write what? Normal butyl, or you can say N-butyl. N means what? Normal. Suppose this pattern of group is present, known as what? Isopropyl. Suppose this group is given, you can write what? Isobutyl. Why? Because this group is said to be what? Iso group. Isobutyl. Suppose this pattern of group is given, then one carbon atom linked with other 3 carbon atoms, That's why the name of this alkyl group is what? Tertiary. Tertiary butyl. Why butyl? Because alkyl group contain total 4 carbon atoms. This is said to be what? Secondary. Butyl. Suppose this pattern of group is given. This is called what? Neo. Neo pentyl. Normal, iso, neo, primary, secondary and tertiary. Generally used in common or you can say trivial name. But according to NCERT, in iambic name you can also use such type of prefixes. But generally used before the common name of organic compounds. Let us consider some examples of haloarenes. So, nomenclature of haloarenes pattern. Suppose this compound is given, we can write what? 1-chlorobenzene. Suppose this pattern of compound is given, Fonseca group always go to minimum position. So the name of this compound is what? 1-chloro-4-methyl-benzene. Third one, suppose 2 choline are present in benzene nucleus and both choline are very near to each other, that is 1 and 2 position. Then commonly you can say what? This position is called what? Ortho position. The iambic name is 1,2-dichlorobenzene. In common name you can use ortho-dichlorobenzene. Similarly, we can write down the name of meta-dichlorobenzene or you can say para-dichlorobenzene. Suppose this pattern of compound is given, we can write what? 1-chloro, 1-phenyl-methane. Because in this compound, 2 types of chain become present. One is called open chain and the other one called what? Closed chain. And the parent of this compound is what? Methane. So the name of this compound becomes 1-chloro, 1-phenyl-methane. Suppose this pattern of compound is present. Here 2 different halogens are present. One is called fluoro and the other one is called what? Chloro. So according to alphabetical order, we can write down the name of this compound become 1-chloro, 4-fluorobenzene. Because chlorine always go to minimum position. So such are the examples for what haloarine pattern. If the naming of organic compounds are given, then you can write down the structure of organic compounds in the similar manner. For this, consider different type of examples. Suppose if we consider question, write the structure of the following organic compounds. Suppose first is given 2-chloro 3-methyl pentane. So pentane means carbon containing chain, that is 1, 2, 3, 4, 5. Total number of carbon atoms 5. Numbering become 1, 2, 3, 4, 5. 2-chloro 3-methyl. Other hands of carbon atom satisfied by hydrogen atoms. So the name of this compound is 2-chloro 3-methyl pentane. Suppose your NCERT second question, like 4 tertiary butyl 3 iodo heptane, longest continuous carbon atom containing 7 carbon atom chain, that is 1, 2, 3, 4, 5, 6, 7. 4 tertiary butyl. It means in 4th carbon you can link tertiary butyl. You know very well this group is said to be what? Tertiary butyl. So we link tertiary. This is said to be tertiary butyl. 4 tertiary butyl, 3 iodo. And the carbon atom satisfied by hydrogen atom, because carbon atom have got 4 hands. Next one, suppose 1,2-dichloroethane. Ethane means 2 carbon atoms. 1, 2. 1, 2. Other ends are satisfied by hydrogen. So the epic name for this compound is 1,2-dichloroethane. It is also known as ethylene chloride. It is also called gem dihalide. If 2 similar halogen groups are present in different carbon atom continuously, then we use prefix gem in common name called what? Gem dihalide. Suppose this pattern of compound is given. The epic name is what? 1,1-dichloroethane. 1,1-dichloroethane. And the common name for this compound is ethylene dichloride. ethylene dihalide, which is also known as weak dihalide. In common name you can write what? Weak dihalide. Weak means similar halogen atoms present on the same carbon atom. Generally, gem and weak are used before the common name of the organic compounds. Our next important topic in this lesson is isomerism. Two patterns of isomerism are possible. First is called structural and second one is stereo. Structural isomerism and second one is stereo. In a structural isomer, generally position chain and ring chain isomers are possible if we consider structural isomers. But for stereoisomers, for haloalkane and haloarenes, two possibilities arises. First one is known as geometrical and second one optical. The most common isomer in this lesson according to NCERT is structural isomer. Generally, position and chain isomers are very common. For position and chain isomers, you must have an idea of degree of carbon atom and degree of hydrogen atoms. If you have a knowledge of degree of hydrogen, then you can find out how many structural isomers of different types of haloalkanes, or you can say haloarenes. Suppose you have a given this compound. Here only one type of degree is present, that is carbon 1 degree. The hydrogen atom linked with 1 degree carbon known as what? 1 degree hydrogen atom. So for ethane we can form only one alkyl group like this one, because only 1 degree present. The number of degree decide how many alkyl groups are present in such alkane. An alkyl group linked with halogen to produce what? Haloalkane. Similarly, if we consider propane, this carbon is 1 degree, this one again 1 degree, here 2 degree. So two patterns of alkyl group can form. Either you can remove hydrogen from 1 degree, and the second one hydrogen removed from 2 degree. So two patterns of alkyl group can form if propane is given. Similarly, if butane is given, here this carbon 1 degree, 1 degree, this carbon is 2 degree, again this is 2 degree. Both 2 degree carbon atoms linked with 1 degree hydrogen. So this 2 degree and this 2 degree both are similar. So two types of alkyl group can form if butane is given. First is called what? Normal butane. Second one you can write what? Suppose hydrogen is removed from this one. This is called what? Secondary butane. Suppose you have a given 5 carbon atom alkanes like CH3, CH2, 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 CH3. Again, suppose given CH3, CH3, H, CH2, CH3. CH3, 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 CH3. This is called normal pentane, N-pentane. This is said to be what? Isopentane. And this one called what? Neopentane. How many alkyl group can form if different pattern of alkanes are given? First you decide how many types of degree of hydrogen atoms are present. The number of degree of hydrogen atom decide how you can form number of alkyl group, which help to predict the number of structure isomers. Here the carbon atom 1 degree, 1 degree, 2 degree, 2 degree, 2 degree. This 2 degree directly linked with 1 degree, again 2 degree linked with 1 degree, but this 2 degree linked with only 2 degree. So all 2 degree carbon atoms are not similar. So we can write here what? Here 2 degree dash, because all 2 degree carbon atoms are not equivalent in all respect. So here first hydrogen is removed from 1 degree hydrogen, second one from either this 2 degree or this 2 degree, and the third one 2 degree dash. So 3 alkyl groups can form. Like suppose if you remove this way, second one you can write, suppose hydrogen atom is removed from this carbon atom, and third one for the center carbon atom. So 3 alkyl groups can form if normal pentane is given. Similarly, here we can form how many alkyl groups? This is 1 degree, 1 degree, 1 degree, 2 degree, 3 degree. All 1 degree hydrogen atoms are not equivalent in all respect. So we can write here 1 degree dash. So 4 alkyl groups can form in similar fashion. Here all carbon atoms are 1 degree, and 1 degree carbon atoms are linked with only 4 degree hydrogen atom. That's why only 1 alkyl groups can form. So suppose C5H11Br is given, and you have to write down the total number of structure isomer. So first you decide which type of alkyl groups are present. If 5 carbon atoms are present, then 3 structural pattern of alkyl groups are possible. That is normal, pentyl, isopentyl and neopentyl. From normal pentyl you can say what? 3 alkyl groups are possible. If alkanes is given, here 3, this one is said to be what? 4, and last one 1. So total 8 structure isomers are possible. Why? Because first you arrange this compound in normal pentane pattern, second one isopentane pattern, and third one is neopentane pattern. If normal pentane is given, then 3 pattern of alkyl groups are present. If alkyl group link with halogen to produce what? Alkyl halides. So 3 pattern of alkyl halide obtained from normal pentane. Similarly, 4 alkyl groups can form from isopentane. So 4 alkyl group is what? Means 4 different patterns of alkyl halide can form if isopentane pattern of compounds are given. Similarly, if C5H11 arranged in neopentane pattern, then only 1 alkyl group can obtain. So if we add, we obtain total what? 8 structure isomers are possible. So if number of carbon atoms are given, then we can easily predict how many structures isomers of different types of haloalkanes are possible. In our next lecture, we will consider the nature of different type of alkyl halides compounds. Thank you.